Okay, in this video I'm going to show you how to use the Nullschool wind visualizer. It's actually called an earth, excuse me, an earth visualizer because we can see lots of different things on here. But this is what it defaults to, and this is not only an animation or a computer model of winds. It's based on real data stations and buoys, ships, all kinds of satellite data from around the world are available that can then feed into this model for it to recreate the winds on the surface of the earth so that we can see them with streamlines. These are the little streamlines. It can also predict what the wind and weather are going to do, like where this tropical storm may go in the future. But it can also go back and look at some big snowstorms or other hurricanes that we've had since about 2014 and replay them. Okay, so what do we see here? These are surface winds, and the you'll notice there's a lot of rotation, things that are spinning. Right here we have a tropical storm, and it may actually be a hurricane. If I zoom in on it, I can see what the wind speeds are around it. I'll click on the earth over here, and yeah, we have air surface. Okay, so click right here next to that tight red area there. The wind speed is 72 miles per hour. So this is a little bit less than hurricane strength, but it's pretty strong tropical storm. But you'll notice that storm is turning counterclockwise and in toward the center. And that's what you expect of a low pressure center in the northern hemisphere, that they will be wrapping around a center and towards the middle counterclockwise. You notice over here, you see air that's moving in a clockwise direction and away from the center. Nothing's moving into the middle, everything's moving away. So this is high pressure. High pressure is clockwise in the northern hemisphere and away from the center. Low pressure centers in the northern hemisphere are counterclockwise and in towards the center. So over here, you can see in the Pacific Ocean something sort of similar. Here's one that's turning counterclockwise. So that's a low pressure center. It's spiraling into the middle. But right over here, it's spiraling clockwise away. So this would be the high pressure center. Okay? In fact, you might even remember that there was that rain shadow effect where the rains fall in Hawaii on the eastern slopes. This is what causes it. There's a semi-permanent high pressure here that sits in this part of the Pacific, and it causes these trade winds that force the winds up the flanks of Hawaii so that it produces all the rain on the east side, and then it produces the rain shadow on the other side. It's all because of this high pressure center. Okay, so let's take a look at some other things that we can see with the wind modeler. And then we'll come back and look at some weather fronts. Okay, you'll notice here, I want to point out this thing right here. You see these two air masses colliding in the Midwest. You have air coming from the tropical Gulf of Mexico and up north. So that's bringing moist, humid, warm air from the south up against cool continental polar air coming out of Canada. So there's a frontal boundary right here, and this would be called a cold front. It could be a stationary front, but usually the cold air wins, and it will be called a cold front, right along that boundary between the two air masses. Okay. We also have a front out here over the ocean, continental polar coming from Canada, and more tropical, moist air coming up from the southern Atlantic, southern Atlantic right here. Okay, so the frontal boundary is right there. But we have a better one we'll look at in a moment that helps us see things a little more clearly. This is a famous feature right here, this line. You have winds coming from the southern hemisphere crossing the equator here and all pointing north. And then you have winds from the northern hemisphere coming down like this. They meet in what's called the intertropical convergence zone. and it basically sits right on the equator. It's still in the northern hemisphere right now, but as we go into winter, this blue area, this blue streak you see right here, is going to end up down here as we go into winter. Okay. Now let's look at some other features of the wind modeler and ways to play with time, going forwards and backwards in time. Okay, so let's look at ocean. What you see now are the waves, ocean waves. Okay, not too interesting because there's not much we can do with it. But ocean currents looks more interesting. And you can see that here's this famous warm current going up the coast of Florida and up past Virginia and then out into the Atlantic and over to England. And this is the famous Gulf Stream that then becomes the North Atlantic current that goes over to England and keeps its climate relatively mild. Okay, and you'll see some warm water coming back this way. Look at those streamlines coming back towards the east. And this is all warm water that has been piled up over here and is now flowing backwards towards the east. It looks like this could be the beginnings of an El Nino event, which I hear they're talking about. But this is a major climate shifter because the warm water comes back over to where there's usually cooler water and in fact affects the climate on this side of the ocean. Okay, so that's the ocean currents. We can also look at the sea surface temperatures. And this is just absolute temperature. How hot is the water? If I click over here in this purple area, I can see that the water is 87.2 degrees. That is warm. That would be, it's almost like a bath. And right off the coast of Mexico here, 86.9. And that's about the two warmest spots I can see right here. But we can see off the coast of California, only 60 degrees. Right here off of LA. Here's LA. Only 65 degrees in sunny Southern California, which is why people have wetsuits there. And here you have the Gulf of Mexico, I'm sorry, the Gulf Stream off the coast of Georgia and South Carolina, 79, almost 80 degrees. Here we are off the coast of Virginia, 62, much colder. So you can see why the climate changes suddenly from here, from the tropical area down here to the more moderate mid-latitude Virginia climate, because we have the influence of a cooler climate or a cooler current. Up here off the coast of Canada, the water is only 35 degrees. It's a big difference. Okay, so now this one is more interesting to me because it tells me how much the temperatures differ from normal. Wherever you see red and orange here, it's warmer than normal. And where you see blue, it's colder than normal. Where it's blackish, it's normal. Same as what we get normally. So you can see over here we've got some warmer than average water off the coast of the United States. And actually off California, it's already getting warmer than normal. That tells me that this is the beginning of that El Nino. The warm waters that are coming back are starting to fill in where it's supposed to be colder. This blob here of warm water that's now around Hawaii, if that moves this way, it's going to cause some climate impacts over here on the west coast. It's going to make it much wetter. Okay, so we'll be watching that throughout. By the end of the school year, we might be seeing the effects of this warm water coming back to the east. All right, so now we're going to move on to the last thing that we would do with the wind modeler. We can look at the jet stream, and we can look at the time, distant weather events. So first we'll do time. To do this, I'm going to go back to air, and I want you to notice that up here at the top it says current, pound current. This is the current conditions. That's right now. If I go back one day, minus 3 hours actually, minus 3 hours, it's still today, but it's actually the past. It's not what's happening right now. And you can tell because it says 2018, 10:30. So that's October 30th, 2018. And we had a very significant weather event here back in 2015. where we went to school, and it was just a dusting of snow. But it got worse and it got worse. Took everybody hours to get to school. There were accidents. I know it took me more than 3 hours to get to school. And then when I got to school, they said we're going home. So it was a real waste of time. So let's see what the weather looked like on that day. January 6, 2015. So you go up here to the top and change the 2018 to 2015. Change the month to January to number 1, and change the day to the 6th. And let's see if it will go there. It did. Okay, on January 6th, we got snow. We got a lot of it. And or not a lot of snow, but we got a lot of ice that came with it, and slippery road conditions. And what happened was this cold front came through. If I back it up in time, if I can try to do that. If I can go back in time, you'll see that cold front moving back towards the United States. Yep, see, I'm bringing it back. So it actually happened early on the 6th. It was a fast mover. And keep going back until it's right on the coast. Now we're on the 5th, so let's just see. So here's that cold front, and you can see that when the cold front came through, it was being pushed eastward by the streamlines coming out of the northwest. These streamlines are the continental polar air coming in from the west, and these lines coming up from the south are the maritime tropical air coming out of the Caribbean. So this is warm and moist air over here. This is colder and drier air over here. In this boundary right here, this whitish looking line, that's the front. That's a cold front because the cold air is pushing in this way. Notice that the wind shift is 90 degrees from the northwest here, from the southwest here. That's a 90-degree wind shift, and that's classic for a cold front. Okay? If we move forward a little bit, you might see it develop a little bit more. See, it's getting stronger. Okay? That's the front that brought us that weather that day, that got us out of school after we were already here. Okay? Now, the last thing I want to show you is the upper level winds. I'm going to go up to about the 500 millibar level. And it doesn't really matter which day. Right now I'm still on January, and you can see what really forced that cold air into our area on January 6th, 2015. This is the jet stream. These winds are extremely fast. This is like a river of air within the air. It's coming around, comes over here, it's coming across the Atlantic, crosses into Canada, in northern Canada, and then when it comes across Canada, it dries out. And it brings us that cold, dry air that blew in and ran into the moist air that was here already, and we got snow. But how fast is that going? And we can click on it, and it will tell us the wind speeds. 132 miles an hour. You might be able to find faster. 141. 156. 157. Okay? You can imagine if you're an airline pilot, flying against this across the country would really use up a lot of gas. So the pilots try to avoid it and fly a different route, try to fly outside of it. But if you were flying from the west coast to the east coast, you can save a lot of gas, a lot of jet fuel by riding the jet stream. So if you ride the jet stream from the west to the east, not only is your trip a whole lot shorter, maybe an hour shorter, it saves a lot of fuel. Okay, so that's how you use this thing. To get to the higher level jet stream, we have to go up high enough to where the pressure's lower. So at the surface, pressure's about 1013. We can go a little above the surface at 1000, but as you go to lower and lower pressure, you're going higher in the atmosphere. And the 500 millibar pressure is roughly about the elevation of the jet stream. Okay, and that's it. To take this back to the start, you click now.